Hello everyone, welcome to MindMatrix Learning. Good evening all of you. Am I properly audible and visible to all of you? Please confirm once. Am I properly audible and visible? Hi Abhas, good evening, welcome. Okay, let's wait for 1 minute and then we will start. Yes, so everyone do share this session with all your friends, those who are preparing for GATE CS and GATE DA, those who are going to appear for this 2025 exam. So as of now, like we will be covering DBMS previous year questions. Okay, so what we have planned is we have divided this uh, PYQs into modules. So based on the modules, we will be covering the DBMS questions. So today we will be starting with a relational model and relational model questions. So I will be covering in two parts. Okay. Okay. So today we will be covering questions based on keys, integrity constraints, functional dependencies, and closure. Okay. So based on these concepts, we will be covering the previous year questions in today's session. And in the next session, we will be covering all the previous year questions based on normalization. So like this, I have planned all the, PYQ sessions of this particular subject, DBMS. Okay. So let's get started with the first question. And this is a very simple question, like you can answer within 2-3 seconds also. So I have included this question as well, as it was asked in GATE 2023. So I thought that let's include the easy questions as well along with the moderate questions. Okay, so let's read this question now, and what you can do is you can answer in the comment section. Okay, so let's see this question from 2023 GATE CSE 2023. Which one of the options given below refers to the degree or arity of a relation in relational database system? Very simple question, and it was asked for around for 1 mark. Okay, and you can easily answer this question. So what refers to the degree of a relation? When we say degree of a relation, what does that mean? That simply means what? Number of attributes. Yes, so whenever we say degree, that means we are talking about the number of attributes. And if I ask you a simple question, another question, that if I ask you the cardinality of a relation, if I say what is the cardinality, what do we mean by cardinality of a relation? Can you answer this? In relational database system, what is cardinality of a relation? That is nothing but the number of rows, you can say, number of tuples, you can say, tuples or rows or records, right? So that is nothing but the cardinality of the relation. Is this clear? So according to this, degree of a relation in relational database system refers to the number of attributes. So option A is the correct answer here, number of attributes of its relation schema. Option A is the correct answer. Yes, Isaac Newton has answered this question correctly. Yes, if they ask cardinality of a relation, then it is number of tuples. That means in that case it will be option B. Okay, let's proceed to the next question now. GATE CSE 2014 set 2. So I have arranged the questions based on the concepts. Okay, so let's see this question now. Let's read the question here. Given an instance of the student's relation as shown below. So this is a student relation given to you and an instance is given to you. What do you mean by instance? Snapshot of the system, you can say, right? Snapshot of the table. So what are the records currently present in that table? That is nothing but the instance, snapshot, right? So now the question is, for student's name comma student age to be a key for this instance. Now if they are saying that if this has to be a key for this instance, what value of x should not be equal to, that we need to find out. What value of x should not be there if we want student name comma student age to be a key for this instance? Yes, can you answer this question? Again, a simple question. Yes, anyone? So here they are talking about student name. So if you carefully see this, they are talking about student name and student age. These two attributes they are talking about, right? Now if I want these two attributes to form a key, so student name comma student age, I want these attributes to form a single key, then definitely whenever I say key, that means key means what? Now here when we simply say key, that means we are referring to the candidate key. So now if I want certain set of attributes to be a key, definitely it should be able to identify a tuple or a row uniquely, right? So here if you see student name, Shankar is there and here it is X. Now if I want this, if I want this entire tuple to be uniquely identified, then how can I do that? So definitely you can see here Shankar and Shankar 2 times present here. Definitely X cannot be equal to 19, because if X is equal to 19, in that case this will not be able to identify the tuple uniquely, right? Then this key will not be able to identify the tuple uniquely. That is the reason X cannot be equal to 19. Is this clear to all of you? Many students have answered this question correctly. It was again a simple question, I would say. Yes. Okay, so let's proceed to the next question now. This is from GATE CSE 2014 set 2. So today in this session, we will be solving around 25 questions, all previous year questions, okay, based on the keys concept, integrity constraints, functional dependencies, and the closure. So based on all these concepts, we will be solving the questions today. And it is around 25 questions. So it is going to be, as we have mentioned, it is going to be a sprint. So yes, we are going to solve the questions, quickly, we can say, right? But wherever the concept is required, I will discuss the concept in a brief also, so that you can get the idea if you are not aware of the concept. So let's talk about this question now. The maximum number of super keys for this relation R, which is having 4 attributes E, F, G, H, and with E as the key. Again, it is mentioned that E as the key. That means it is referring to what? It is referring to the candidate key. Whenever they just say key, that means they are referring to the candidate key. So here we need to find the maximum number of super keys. What is super key? Super key, you can say, if I have a super key, let's say X, then I should be able to identify the entire tuple uniquely. That I can say it is a super key, right? And what about the candidate key? If I say this X is my super key, that means I'm able to identify the entire tuple uniquely. What about the candidate key? Candidate key is nothing but the minimal super key. Minimal super key, right? Candidate key is nothing but the minimal super key. That means you cannot have, you cannot remove any attribute from that, right? If you remove any more attribute from the candidate key, then it will no longer be a key, right? So that is the reason we always say candidate key is nothing but a minimal super key. That means minimum number of attributes are there by which still you will be able to identify the tuple uniquely. So now here we need to find the maximum number of super keys, and here it is given already that E is our key. So you don't have to find out, and you cannot find out without the functional dependencies as well. So here E is your key. So E is your candidate key here, right? Now when I talk about super key, So can I say that if E is my if E is my candidate key here, then you can add any number of attributes here. You have F, you have G, you have H. So you can add these attributes. So you have two choices here, either to add this F or not. Similarly, you can add this G or not. Similarly, you can have H or not. So there can be many combinations will be formed, right? So whenever we are forming the super key, so here I can have many combinations possible. Now we have two choices for the remaining attributes, that is F, G, H. So if I have two choices, so 2 into 2 into 2, how many attributes, remaining attributes? 3. That means 8 maximum number of super keys can be formed. Is this clear to all of you? Because why I'm saying that if you can add more attributes, see, candidate key is also your super key, right? Now, if you add even a single attribute, again, this is a super key. EF is also a super key, right? If you add, let's say EFG, this is also a super key. EG, this is also a super key. So for the remaining attributes, you have two choices whether to add it or not. Because any superset of candidate key will also be a super key. This is the concept. Any superset of the candidate key will also be a super key. So here 8 super keys can be formed because you have two choices for the remaining attributes to form a super key. Is this clear to all of you? So 8 will be the correct answer here. Any doubt, anyone? If you have any doubt, please ask in the comment section. Yes, so we have Ashish, Abhas, Pravat, Patra. Okay, so anyone having any doubt in this question, please let me know. I hope this is crystal clear to all of you. Okay, so if you have any doubt, you can ask in the comment section, I will answer. Okay, now let's proceed to the next question. That is from GATE CSE 2011. So let's read this question now. Consider a relational table with a single record for each registered student with the following attributes. So here they are saying that these are the attributes present in this particular relational table, right? That is registration number, okay, UID, bank account number, name, hostel room. So these are the attributes that are present. Now we need to find which of the following option is incorrect. We need to find which of the following option is incorrect here. Clear? So the first option is bank account number is a candidate key. Now let's read what they have given the information about the bank account number. Let's identify, let's try to find out whether it can be a candidate key or not. Okay. So bank account number, it is unique account number at the bank. Bank account number is the unique account number at the bank. Okay. And a student can have multiple accounts or joint accounts. So if I have a student, let's say S1, he can have multiple account numbers. He can have a multiple account numbers, right? This attribute stores the primary account number. Okay, so when a student can have multiple account numbers, do you think that you can make this bank account number as a candidate key? Because candidate key should be able to identify the entire tuple uniquely. But here you will not be able to identify if that student is having multiple accounts or basically joint accounts. Why so? Because joint accounts means, let's say S1 and S2, both the students are having a joint account. Let's say the account number may be A1. Now in this case, if you are making this as your candidate key, then you won't be able to identify the tuple uniquely. Why? Because both are having the same account number. And if both are having the same account number, in that case, you cannot make bank account number as the candidate key. So that is the reason this is the incorrect statement. This is the incorrect statement here. Is this clear to all of you? Do you have any doubt, anyone? Yes, any doubt, anyone? Okay, what about option B? Registration number can be a primary key. So what is registration number? It is a unique registration number for each registered student. Yes, definitely. Definitely you can make this registration number as a primary key. So this is correct. This is correct. There is no problem in this. This is correct. What about option C here? UID is a candidate key if all students are from the same country. Can we make UID as a candidate key? UID is unique identity number. Unique at the national level for each citizen. Yes, if for each citizen it is unique at the national level, definitely UID can be made as a candidate key, right? If all the students, this is also important, if all the students are from the same country, so definitely this is also correct statement over here. Option C is also correct here, but we need to find out incorrect, and option A is incorrect so far. What about option D here? If S is a super key such that S intersection UID is null, then S union UID is also a super key. So what it is saying, let's try to understand. S is a super key. They have given you that S is a super key, and they are saying that if you find the intersection of S and UID, right, that is null. That is null. That means the intersection is phi. Okay. Now, if the intersection is phi, definitely this UID is something else. Maybe let's say, maybe it is a combination of some attributes. Let's say, for example, it is combination of some AB attributes out of these, right? Now, if you are finding this intersection, it is phi, it is given to you. Then if I ask you union of S and UID, so that means if S is already a super key, if you are adding more attributes to it, definitely this also be a super key. Because any superset of super key will also be a super key. If you add more number of attributes, then also it will be a super key. So this is also correct statement over here. S union UID is also a super key here. Is this clear to all of you? Do you have any doubt, anyone? If you have any doubt, please ask. Crystal clear? And one more thing, if you want the PDF of all these slides and the solutions that we are solving over here, then you can join the Telegram group. The link will be provided in the description as well as at the last slide. Okay, so that you can get the complete PDF also for all these solutions. Now let's proceed to the next question that we have, that is from GATE CSC 1997. And this is based on the referential integrity constraint. Okay, so let's try to read this question. But before that, just let me know once in the comment section if you have any doubts so far. So we are going to solve almost every question from these concepts. Okay. So total around 24 to 25 questions we have in this session. So let's proceed to the next question now. Let relation R is given having 3 attributes A, B and C, and S is given having 3 attributes D, E, F. Be 2 relations in which D is the foreign key of S. Okay, so what it is saying, let's say you have R relation here A, B, C. Okay, and here you have S, which is having 3 attributes D, E, F. Now what else it is mentioned over here, that D is the foreign key of S. So D is the foreign key of S, that refers to the primary key of R. So this is your foreign key, and let's say it is referring to some primary key of R. Maybe it is not mentioned what is the primary key, but let's assume, let's say A is your primary key. Okay, that you can assume. Consider the following 4 operations on R and S, and which of the following can cause violation of the referential integrity constraint above. Yes, I want you to answer this. Think about it and let me know what should be the answer. Everyone, what do you think? D is a foreign key which is referring to a primary key of relation R, and usually it happens, right? Foreign key usually refers to the primary key of the other relation, or for the same relation also. Self-referential is also possible. Yes, what do you think? Everyone, let me know in the comment section. What should be the correct answer here? Which of the following operations? You have 4 operations given to you, right? Which of them can cause the violation of referential integrity constraint? Let's see how many of you can answer this correctly. Let's say if I'm inserting into R, what about the first one? If I insert into R, can it cause violation of referential integrity constraint? What do you think? Can it cause the violation of referential integrity constraint? No, right? It cannot cause. It cannot cause. Samyadeep Saha is saying answer should be B. Okay. Let's see here. Insert into R. If I'm inserting something, let's say maybe 1, 2, 3, and some values are present over here, right? If I'm inserting, let's say 4 here as well, then even if I don't have entry of 4 here in relation S, it is not going to impact, right? Are you getting this point? So if I make insertions in this relation R, there will be no violation of referential integrity constraint, because the values that are present over here for D, that will be present in the relation R for the attribute A here. So insertion into R will not cause any violation. No violation at all. No violation at all. Right? So you can easily insert. There will be no violation, or it cannot cause violation basically. What about second statement? Insert into S. Now this is very important. Insert into S. Carefully say this. If you are inserting something, let's say you have 4 values here for this attribute A, 1, 2, 3, 4, and let's say if I insert 5 over here for this attribute D, then you can have violation. Why? Because 5 is not present here, and it has to be here. If you are inserting 5 over here, it has to be present here, because D is your foreign key which is referencing to the primary key of relation R. So that is the reason this will cause violation. Yes, can cause violation. Yes, may cause violation or can cause violation, you can say, right? If you are inserting some value which is not present over here in relation R for this attribute A. What about the third one? Here? Delete from R. Can it cause violation? Delete from R. What do you think? Yes, it can cause violation as well. Why so? Let's say you have some entry over here for maybe for 3. Let's say you have the entry over here for 3. And if you are deleting this particular tuple from this relation R, then definitely you cannot have 3 also here. Right? You cannot have 3 over here if you are deleting 3 from the relation R, because this is a foreign key over here which is referencing to this relation R and the attribute is A. So you cannot have this. So definitely it can also cause violation. It can also cause violation. Okay. So focus on this word that they have mentioned, can cause, right? In some cases, it will not cause as well, right? So may or may not, depending upon what you are deleting or what you are inserting in S. Clear? What about this one, last one? Delete from S. Can it cause violation? Delete from S. No, it won't cause violation. Why? Because even if you are deleting 3 or maybe 5 or maybe some entry for 1, then it is not going to cause any violation, because you are deleting from S, right? You are deleting from S and D is your foreign key over here. So no violation. No violation at all. Is this clear? So what will be the correct answer over here? So we need to find which can cause violation, second and third. So yes, option B is the correct answer over here. Yes, that is absolutely correct, Samyadeep. Option B is the correct answer over here. Now let's see this question now. GATE CSE 2005. Let's try to answer this. I hope previous question is crystal clear to all of you. If you have any doubt, please ask. Let's try to solve this question now. So let's read this question. The following table has two attributes A and C. A is the primary key and C is the foreign key, referencing A with on delete cascade. With on delete cascade. So A is your primary key here and C is your foreign key, and C is referencing to A itself. So C is referencing to primary key of the same relation. So it is a self-referential. So it is as it why it is referencing to the same relation, right? So it is self-referential. Now the question is the set of all tuples that must be additionally deleted to preserve referential integrity when the tuple 2, 4 is deleted. So when you are deleting 2, 4, here it is this tuple. If I delete 2, 4, then additionally which tuples have to be deleted, right, in order to preserve the referential integrity constraint? Can you answer this? So let's try to solve this. If I delete 2, 4, let's say I delete 2, 4, right? Now if I'm deleting 2, 4 and A is my primary key, that means now I cannot have 2 in the foreign key, because primary key is 2, right? If I have deleted that tuple, then I cannot have 2 in the foreign key attribute, right? I cannot have the value 2 in the foreign key attribute because it is referencing to primary key. So wherever we have 2, I have to delete it. So can I say I have to delete 5, 2 because 2 cannot be present over here? What else? I have to delete 7, 2 also. But now in order to preserve the referential integrity, I have deleted 5, 2, 7, 2. So wherever I have 5, I have to delete that also because 5 cannot be present in the foreign key. So can I say 9, 5 will also get deleted? And what about 7? Do we have 7 in the foreign key? No. Do we have 9 in the foreign key? No. That means now we can stop. We have preserved the referential integrity constraint. And why we are deleting? Because it is already present that we are using on delete cascade. So when we are deleting, we are using cascade property. That means it is going to perform the same operation when you are deleting, right? So we have multiple operations like on delete, update is there, on delete set null is there, on delete cascade is there, right? So there are many operations here. They have clearly mentioned that you have to perform on delete cascade. So additionally, I can say these 3 tuples will also get deleted. So 5, 2, 7, 2, 9, 5, that is the correct answer. Option C is the correct answer over here. Is this clear to all of you? Do you have any doubt so far? Yes, so Abhas and Samyadeep, yes, you have answered this question correctly. That is absolutely correct. So I hope it is clear. Let's proceed to the next question now. Again, based on referential integrity constraint, and this is from GATE CSE 2017 set 2 question. So let's try to read this question now. Carefully see this. Consider the following tables T1 and T2. So there are 2 tables given to us. Okay. Now carefully read this question. In table T1, P is the primary key. So this is your primary key and Q is the foreign key referencing R in table T2. So this is your foreign key and it is referencing to this one. So this is your foreign key. Q is the foreign key which is referencing to R in T2. And on delete cascade is there, right? On delete cascade is there and on update cascade is there, right? So when you are deleting, then also you have following the cascade property. When you are updating, then also you have to follow the cascade property in this scenario. In table T2, R is the primary key. In table T2, R is the primary key. So here, this R is your primary key and S is the foreign key. S is the foreign key which is referencing P in table T1. Okay, so this is referencing P in table T1. Understood? Now, and with on delete set null. So for this scenario, it is on delete set null. When you are deleting, then you have to set the value null. On update cascade. On update cascade is there. Is this clear? Now, in order to delete record 3, 8 from table T1. Now, if I want to delete 3 comma 8 from T1 table. So T1 table is here. If I want to delete this 3 comma 8 from this one, the number of additional records that need to be deleted from table T1 will be what? How many records you have to delete additionally from this table T1 if I delete 3 comma 8? See, if I delete 3 comma 8, right? So that means, see, P is my primary key. That means this 3, wherever it is present in S, there I'm going to do what? I'm going to do on delete set null. On delete set null. Because for this scenario it is on delete set null. It is not on delete cascade. It is on delete set null. That means wherever I have a 3 present in the column S, there I'm going to mention what? I'm going to mention null over here. Right? I'm going to mention null over here. Do we have any other 3? No. That's it. That's it. Right? Now we can stop. So how many additional records you have deleted from table T1? Additional records. 0. There is no need to delete any more records. The answer is 0 over here. Is this clear? Yes, Abhas, that is absolutely correct. Is it clear? Do you have any doubt, anyone? If you have any doubt in this question, please ask. So in these type of referential integrity constraint, you need to carefully read this question. On delete, you are performing whether cascade or set null or which type of operations, right? So you need to focus on that. Is this clear? Fine. I hope it is clear to all of you. Let's proceed to the next question now. And that is from GATE CSE 2012 set 2. Yes. Can you answer this question? Let's just read it and then you tell me the answer, okay? I will wait for your answers. Consider the following statements S1 and S2 about the relational data model. So there are two statements S1 and S2 about the relational data model, and we need to find which one of the following choices is correct. So what this statement S1 says, a relation scheme can have at most one foreign key. So if you have a relation, when I say relation scheme, that means it is talking about the relation schema. So here it is saying that a relation schema can have at most one foreign key. That means you cannot have more than one. Either you are having 0 foreign key or 1, according to this statement. So you need to tell me whether it is correct or not. And what about statement S2? A foreign key in a relation scheme R cannot be used to refer to tuples of R. That means if I have a relation R, and if I have two attributes A and B, so if this is, let's say, my primary key, so I cannot have B as my foreign key, which is referencing to the tuples of R. So according to this statement, this is what it is saying. Now you need to tell me whether this is correct or not. What do you think about these two statements S1 and S2? So if you see the statement S1, a relation scheme, Abhas is saying option D, Samyadeep is saying option D, okay. So S1 is saying a relation scheme can have at most one foreign key, but it is possible that we can have more than one. We can have more than one foreign key as well. We can have more than one foreign key as well in a relation, right? Because it may be possible that one foreign key is referencing to, maybe you are having three relations P, Q, R. Some attribute B is a foreign key which is referencing to the primary key of this one, and maybe we are having C also which is referencing to the primary key of this one. So we can have multiple foreign keys as well. Multiple foreign keys are possible. So this statement, we can say it is incorrect. This is false. This is false. What about S2? A foreign key in a relation scheme R cannot be used. Just now we have solved the question, right? Previously, where a foreign key is referencing to a primary key of the same relation. So self-referential property, that is also possible. So this is also false over here. Both the statements are false. So if both the statements are false, option D, yes, both S1 and S2 are false over here. Option D is the correct answer. Yes. So yeah, few students have given the correct answer. I hope it is crystal clear to all of you. Let's proceed to the next question now. This is from GATE CSE 2022. Again, a very simple question based on the number of keys that are possible. Can you answer this question, everyone? Now, this question is little different from the previous maximum number of super keys question. Why? Because in that question, they have directly given you the candidate key, but in this question, they have not given you the candidate key. You have to find out the candidate key, and then only you can tell me what will be the number of super keys possible in this relation R. So first you need to find out the candidate key here. First you need to find out the candidate key here. So here you have this relation R having 5 attributes A, B, C, D, E. So how we can find the candidate key? It is very simple. So you need to find out those attributes which are not present on the right hand side of the functional dependency. So if you see here, C, D, E are present. So that means C, D, E are present. That means A and B are not present. So what does that mean? That means A, B has to be present in every candidate key. A, B has to be present in every candidate key. Why I'm saying so? In every candidate key. Why I'm saying so? Because if you are not including A, B, then there is no way you can have all the attributes, right? There is no way you can have all the attributes. So AB has to be present in every candidate key over here. So let's say if I assume that, let's say AB is my candidate key. Let's try to find out whether AB is the candidate key or not. So in order to find out that, you need to find the closure of AB. So closure of AB will be A, B, what else? Using AB you can find out C, you can get C also. So yes, C will be also be there in the closure. Using C you can get E also, so E will also be there. Using BC you can get D also, so D is also there. That means all the attributes are present. Yes or no? All the attributes we are getting in the closure. That means AB is your candidate key. Yes, AB is your candidate key over here. Any other candidate key possible? No. Here it is not possible to get any other candidate key. Here it is not possible to get any other candidate key. Are you getting this or not? Samyadeep is saying 24 should be the answer. Are you sure? See, AB is the candidate key over here. Is it possible to have any other candidate key? Even if you find, AB has to be part of every candidate key. Now, if you are including AB, obviously it's able to find out all the attributes. So this is the only candidate key possible here. Now, if AB is the candidate key possible here, how many remaining attributes you can have? Because we are talking about the number of super keys. Any superset of candidate key is also a super key, right? So now remaining attributes are C, D, E. So you have C, D, E. Again, 2 choices, whether to include this or not. 2 choices for D also, 2 choices for E also. So you have 2 choices for C, 2 choices for D, 2 choices for E, right? So that means 8 super keys are possible. 8 super keys are possible here. Is this clear to all of you? Total number of super keys possible are 8 here. 8 is the correct answer. Any doubt, anyone? Very simple question. If you have any doubt, please ask. And guys, do like the session, share with your friends. Okay, those who are preparing for 2025 GATE CS and DA, because this subject is very important for both. Is this clear? Samyadeep, previous question, 8 will be the answer, right? Now let's try to answer this one. GATE CSE 2016 set 1. Again, a question based on super key. Try to answer this. Which of the following is not a super key in a relation schema with attributes v, w, x, y, z, and primary key is given, that is vy. What is primary key? See, super key is a key which can identify any tuple uniquely. Candidate key is your minimal super key, and primary key is one of the candidate keys selected can be selected as a primary key. So if you have many candidate keys, you can select any one of them as your primary key. Okay, that is your primary key. So what will be the answer here? Okay, so you considered A and B separately. No. AB has to be part of it. Combined. Yes, it should be combined in the previous question here, right? So make sure you don't commit this mistake again, because this is a very silly mistake. Okay, so V and Y is your primary key over here, right? This is your primary key. Now we are talking about super key. Can I say that VY, if is your primary key, definitely it will be present in every super key? If this is your primary key, definitely it will be present in every super key. It has to be present, right? So if you see option A, VXYZ, so V and Y is present over here. So yes, this can be a super key, no problem. VWXZ. Now here Y is not present. Here Y is not present. So this cannot be a super key. This cannot be a super key. What about option C? VWXY. VY is present. Yes, this can be a super key. Again, this can also be a super key. So option B is the correct answer over here. Why? Because VY has to be part of, as it is a primary key, it has to be part of every super key, and Y is not present over here in option B. That's why this cannot be a super key, because we need to find which one is not a super key. Simple question. Now let's try to answer this one from GATE CSE 2000. Okay, so this is based on functional dependencies. Let's read the question carefully. Given the following relation instance. So this is an instance given to you. So there is a relation having three attributes x, y, z, and an instance is given to you. Instance is what? Instance is nothing but the snapshot of the system. That means at the current state, what are the records present in this relation. So this is the instance given to you. Which of the following functional dependencies are satisfied by the instance? They are talking about satisfied by the instance that is given to you, not by the schema. Okay, so let's see. So option A, xy determines z. So I hope you know that if I'm saying x determines y, what does that mean? What does that mean? That simply means that for all tuples t1, t2, if t1 dot, let's say a, is the same as t2 dot a, then t1 dot b will be equal to, or has to be equal to, t2 dot b, right? This is the meaning of, if let's say they are having they are having two attributes a and b, right? So here also carefully see this. So xy determines z, xy determines z. So here it simply means you have to find out for a one value of xy, right? If whether you are getting different values of z or not. So 1 4 determines 2, fine. Do we have 1 4 anywhere else? No. 1 5 anywhere else? No. 1 6? No. 3 2? No. So far it is fine. xy determines z, it is fine so far. What about z determines y? What about z determines y? 2 determines 4 and here 2 determines 2. Is it possible? Right? Z should uniquely identify y. If I'm saying z determines y, that means z should be able to uniquely identify y. Here z is having value 2 determining 4. Here it is having value 2 determining 2. So that is not possible. So this is not satisfied by the instance. This functional dependency is not satisfied by the instance. What about option B? YZ determines X. 4 2 1 5 3 1 6 3 1 2 2. So this is fine so far. What about Y determines Z? 4 determines 2, 5 determines 3. So yes, every value of Y is uniquely determining Z. So yes, option B is correct so far. That means option B will definitely satisfy by the instance. What about option C? YZ determines X. 4 2 determines 1, right? So y z determines x, already we have checked, that is fine. X determines a z. Now there is a problem here, x determines a z. What is the problem here? 1 determines 2, but here 1 determines 3. So that cannot be possible. So this is also incorrect. What about option D? X z determines y. So here also you have a problem, x z determines y. So if you see here, 1 2 determines 4, right? 1 3 determines 5, 1 3 determines 6. Now there is a problem over here. 1 3 determines 5 here, 1 3 determines 6 here. So it is not uniquely identifying the value of y. That is the reason this is also incorrect. So option B is the correct answer over here. Is this clear? Yes, Abhas and Samyadeep, your answer is absolutely correct. Let's answer this GATE CSC 2002 question. Again, it is also based on this functional dependency. So let's read the question carefully. From the following instance of a relation schema R having 3 attributes A, B, C, we can conclude. Now here it is saying we can conclude that which of the following options is correct. So when I say conclude, that means it is talking about the schema over here. Be careful here. It is not talking about the instance. When I say we can conclude, that means now whatever I say related to functional dependency should be applicable on the entire schema. Are you getting this point? This question is very important. So carefully see here, option A functionally determines B. Let's see here, 1 determines 1, 1 determines 2, 2 determines 3, 2 determines 3. Okay, B functionally determines C here. So that is clearly that is incorrect. B functionally determines C. That is not correct here because 1 determines 1 here, 1 determines 0 here. That cannot be possible. So B functionally determines C itself is, dissatisfied by the instance. And if it is dissatisfied by the instance, definitely it cannot be satisfied by the schema. Understand this thing. If B functionally determines C is not being satisfied by the instance, definitely it cannot be satisfied by the schema. So this option A is incorrect over here. What about option B? A functionally determines B. That is fine. See, A functionally determines B. That is fine based on the instance. Based on the instance you are saying that is fine. But this is important. It may or may not be true. It may or may not be true for schema, right? Why I'm saying so? Because maybe later on, if you are having more records in this, it may be possible that you are having some record like this, maybe 2 determines 4. Then in that case, this will not be satisfied, right? So that is the reason why I'm saying may or may not be true for the schema, but for instance, it is fine. But we are talking about, we can conclude, that means we are talking about the schema here. So option B. So yeah, this is also, we can say incorrect because we cannot say it may or may not be true for the schema, right? I hope you are getting it. What about option C? B does not functionally determine C. Now clearly it is saying B does not functionally determine C. Let's see. Yes, it is not determining C uniquely, right? 1 1 1 0. So this is for sure. Can I say I can definitely conclude that B determines C, B does not functionally determine C? Because if it is not applicable for the instance, definitely not satisfied by the schema as well. So can I say I can conclude for sure this thing, that if it is not satisfied by the instance, definitely not satisfied by the schema as well. Are you getting this point or not, everyone? So there is a difference between satisfied by an instance, satisfied by a schema. So you have to read the question carefully. So here you can clearly say that option C is the correct answer. What about option D? A does not functionally determine B. But here if you see, based on the instance, so far it is fine. So option D is also incorrect here. Do you have any doubt? Anyone? If you have any doubt, please ask. So many students have answered correctly. Samyadeep, Abhas, yes. Alia, your answer is incorrect. It should be option C. I hope it is clear. Now let's see this question. GATE CSE 2021 set 2 question. Now this question is also very important. Let's see here. Suppose the following functional dependencies hold on a relation U with attributes P, Q, R, S and T. So you have one relation having these attributes P, Q, R, S and T. Now these functional dependencies are given to you, right? These functional dependencies hold on this relation. This is given to you. Which of the following functional dependencies can be inferred? Now this term is important. Which functional dependency can be inferred from the above functional dependencies? How can you find out whether it is inferred or not? So you need to find the closure. So let's talk about option A. Carefully see this. Let's talk about option A. PS determines T. How can you find whether it is inferred or not? So what you will try to do is you will find the PS closure. If in the PS closure you get T, then you can say this can be inferred. And you are going to find the closure based on these functional dependencies given to you. So if you find the closure of PS, so P is there, S is there. Using P you can get Q and R also, right? And using RS you can get T also. So can I say PS determines T because PS is determining T also. So I can say this can be inferred. PS determines T can be inferred for sure. What about R determines T? What about this? Let's try to find out the closure. So you have R. What else? Now just by R you cannot get any other attribute. So definitely this cannot be inferred because you are not getting T here. What about P determines R? Let's try to find out the P closure, and you can clearly see P can determine QR, right? So P determines R, definitely it is possible. So option C, this can also be inferred. What about PS determines Q? Let's try to find out PS closure. Okay, we have already find out. Yes, PS can determine Q. So this can also be inferred. So option A, option C, option D. This is your correct answer. This was a MSQ question. Yes, Abhas and Samyadeep, your answer is absolutely correct. Is this clear to all of you? Do you have any doubt so far? Crystal clear? Let's proceed to the next question. Again, a very good question. GATE CSE 2017 set 1 question. Let's read the question now carefully. The following functional dependencies hold true for the relation schema. This is the relation having these 5 attributes, and it is saying that these are the functional dependencies that are satisfied by this schema or hold true on this schema. Which of the following is irreducible? Now this term is very important. Irreducible equivalent for this set of functional dependencies. So now in this question, carefully understand, it is talking about there are 2 terms here, irreducible and equivalent. So that means you need to find which of the following are equivalent to this functional dependency set, and it has to be irreducible also. So can I say this is equivalent to finding the minimal cover? If you have learned this concept, finding the minimal cover, because when I say minimal cover, that is irreducible, and when I say minimal cover, that means it is equivalent also, right? So we need to find what cover. Irreducible equivalent, that means it should be it should be able to cover each other, right? And it should be minimal also. I hope you are getting this point, right? So let's try to understand this concept. Let me just make you understand over here. See, there are 2 things over here. When can we say, let's say we have a set F of functional dependency, F be a functional dependency set, and let's say G be also a functional dependency set, right? Now, when can I say that F is equivalent to G? If F covers G and G covers F. if this is the scenario, if both covers each other, then we say that both the functional dependency set are equivalent. Okay, and we need to find the irreducible here. So let's try to solve it here. Carefully see this, everyone. So we have v determines w, we have vw determines x, we have y determines vx, we have y determines z. So here we can use the concept of finding the minimal cover. Okay, so what we do, there are some steps that are involved, in minimal cover. So we have this y determines yx. So what we can do is, as we know that we can split on the RHS, so we can write this as y determines v, and we can also write it as y determines x, right? So first thing, we can write this. So if I write this, I can get this one, vw determines x, and here I can write like this, y determines v, y determines x, and y determines z. So far we can write like this. Is this clear so far? As a split can be done on the right hand side, so that is the reason why we can write it as this thing also. This is applicable. Okay, now what else we can do? Now we need to find out whether there is redundant functional dependency present over here or not. Now how can we find out the redundant functional dependency? So before that, you can also see that we can, okay, so let's try to find out redundant functional dependency. Now v determines w. Can we get this v determines w by using remaining functional dependencies? So let's try to find out v closure. We are going to get v, what else? Nothing else. That means this is required. You cannot remove it. You cannot remove it, right? You cannot remove it. So v determines w will be there for sure. What about v w determines x? So let's try to find out vw closure. So we are getting vw, what else? That's it. That means this is also required. Can I say this is also required here? Why I'm saying so? Because vw, you are not getting x using other functional dependencies. That is the reason this is also required. What about y determines y? Y determines v, sorry. So let's find out the closure of y. Y can determine x, y can determine z. What else? That's it. Can I say this is also required? You cannot remove it. This is not redundant. I hope you are getting the concept, everyone. What about y determines x? Can you get this? Can you get this by other functional dependencies? Let's try to find out. If you find y closure, you are getting y. Then using y, you can get v also. Using y, you can get z also. Using v, you can get w also. And using vw, you can get x also. So can I say, without even using this functional dependency, I can still get y determines x. That is the reason you can simply ignore this. Because this is kind of redundant, you can ignore this. Y determines x can be ignored, can be removed. Okay, what about y determines z? What about y determines z? So let's try to find out y closure by using other remaining functional dependency. So you are getting y, you are getting v. What else? V, then you are getting w using v. Then using vw, you are getting x. That's it. That means you need this one also. So this is also required. This is also required. So I can remove y determines x from here. So if you see, and what about now? This is done. So we have found out all the required functional dependencies. This is required, this is required, this one and this one is required. Now what can be the last step? The last step will be, what about this one? Carefully see this. vw determines x. Now can we further reduce it? Try to understand. Can we further reduce this one? How can we check? If by finding the v closure, if somehow I can get w, then I can remove w. or if by finding W closure, if somehow I can get V, then I can remove V. Are you getting this point? So if I find V closure, what do you get? You are getting V, you are getting W. Yes, we are getting W. That means now we can remove this one. So V determines X will also be, we can say that now this is the further reduced. We have further reduced it to this one. We have further reduced it to this one. V determines X. Are you getting this? So what will be the final one? The final one will be, you can see here, we are getting from this one, V determines W. So let me write it over here. We are getting V determines W. What else? We are getting V determines X. We are getting V determines X. We are getting Y determines V. Y determines V. And we are getting Y determines Z. We are getting Y determines Z. Is this clear? So this is going to be your irreducible equivalent. Okay, so option A is the correct answer if you match over here. Option A is the correct answer. So we are using the concept of minimal cover. We are using the concept of minimal cover. Is this clear? So now we can say this is the irreducible equivalent. This is irreducible equivalent. Any doubt, anyone? If you have any doubt, please ask. Option A is the correct answer over here. I hope it is crystal clear. Let's see this one now. GATE CSE 2015 set 3. So let's quickly solve this question as well. So consider the relation X is given having these 6 attributes P, Q, R, S, T, U with the following set of functional dependencies. So these are the functional dependencies given to you. Which of the following is the trivial functional dependency in F closure? So if I talk about the closure of F, which one is the trivial functional dependency? So what is trivial functional dependency? If I have X determines Y, if I can say X is a superset of Y, then I can say it is a trivial functional dependency, right? That is the definition of trivial functional dependency. What about non-trivial functional dependency? If you can say X is, so basically there are, based on the standard resources, there are definitions of non-trivial. So you can say if you are finding X intersection Y, right? Then at least some attribute is common. At least one attribute is common, okay, between X and Y. Like for example, if I write something like this, so I'm just giving you the concept over here in brief. If I say AB determines BC, then I can say this is a non-trivial functional dependency. This is non-trivial functional dependency because some part is common. And if I write, let's say A determines A, or maybe AB determines A, then these are trivial functional dependencies because this left hand side is the superset of right hand side. And what about completely non-trivial? This is also one term, completely non-trivial. So if I talk about completely non-trivial, so if I'm saying, let's say X determines Y, if X is not a superset of Y. For example, if I'm writing AB determines CD, this is completely non-trivial. So these are the three definitions: trivial functional dependency, non-trivial functional dependency, completely non-trivial functional dependency. In this question, they are talking about the trivial functional dependency. So if you see the options, PR determines ST. Can I say this is completely non-trivial? Right? But we have to find trivial. So this cannot be the answer. What about option B? PR determines RT. This is non-trivial because some attribute is common. So this is also not our answer. PS determines S. Yes, this is trivial. This is trivial functional dependency. Why? Because left hand side is the superset of right hand side. S is already present over here. Now what about D? PSU determines Q. Again, this is completely non-trivial. So option C is the correct answer over here. Option C is the correct answer over here. Is this clear to all of you? Do you have any doubt so far? If you have any doubt, please ask. And let's try to solve this question now. This is from GATE CSC 2014 set 1. Yes. Let's read the question. Consider the relation scheme R. These are the attributes and the set of functional dependencies. So this is one functional dependency. So these are the functional dependencies given to you on R. What is the key for R? We need to find the key. When I say key, that means we are talking about the candidate key. Whenever they just ask key, that means they are talking about the candidate key. So we need to find which one can be the which one will be the candidate key for R. Now carefully see this. As I told you, in order to find candidate key, you need to first focus on those attributes which are not present on the right hand side of the functional dependency. So G is present, I is present, J is present, KL is present, MN is present on the right side of functional dependency. You can see carefully. But H is not present, EF is not present. So can I say EFH has to be, or we can say must be part of every candidate key. Must be part of every candidate key, because EFH cannot be determined by using functional dependency. So let's try to find out EFH closure, and let's try to find out whether this is itself is a candidate key or not. So you are getting E, you are getting F, you are getting H. What else? Using EF you can get G also. So G is also present over here. Using F you can get IJ also. Using EH, we have EH. So using EH you can get KL also. Using K you can get M. Using L you can get N. So yes, this is our candidate key over here, because all the attributes can be determined by finding the closure of EFH. So yes, this is the candidate key. So if this is the candidate key, you tell me, is it possible that you can have a candidate key of EF? No. Why so? Because candidate key itself is a minimal super key. You cannot further remove any attribute from it. So EFH has to be there. So definitely A cannot be the answer, D cannot be the answer. What about B and C? B, definitely it is a candidate key, just now we find out. And what about C? C is a super key here. Why? Because if you add any attributes to the candidate key, right, any superset of the candidate key will be a super key here. So this is a super key, but option B is a candidate key, and we are talking about candidate key here. Because whenever it just say key, that means we are referring to candidate key, not super key. Is this clear? So option B is the correct answer over here. I hope it is clear. Right? So these previous year questions sessions are kind of quick revision for you. And you will also feel confident, and if you are lacking in some concept, then that will also get clear after watching these lectures. So that's why I plan to just conduct these PYQ sessions for DBMS subject, because this will be helpful for both GATE CS and GATE DA. Okay, so let's see this one now. GATE CSC 2013. Relation R has 8 attributes. These are the attributes present here. Fields of R contain only atomic values. So fields of R contain only atomic values, and F, this is the functional dependency set given to you. Okay. Now you need to find how many candidate keys does the relation R have. So how to find the candidate keys? Again, the same method. You need to find out those attributes which are not present on the right hand side of every functional dependency. G is present, BC is present, CFH is present, A is present. What else is not present? EG is present. So can you say D is not present? Carefully see. D is not present on right hand side of any functional dependency. Rest all the attributes are present. So what can I say? That D must be part of every candidate key. Without D, you cannot have a candidate key possible. Why so? Again, the same reason, because D cannot be determined by the functional dependency, so it has to be there in the key itself. Okay, so let's try to find out whether D itself is a candidate key or not. So for that purpose, we can find the closure of that. So we are getting D. What else? Nothing else. That's it. That means this is not a candidate key. But now if I try to find the superset of this, so let's say we can have a superset like this, AD. We can find the AD closure. We can find BD closure. We can find CD closure. We can find ED closure. We can try to find FD closure, right? GD closure, HD closure. So two attributes combination we can form first. So let's see carefully. AD closure, we are getting A, we are getting D. Using A you can get BC, so BC is there. Using B you can get CFH, so CFH is there. And what else? Using F you can get EG also. All the attributes are there. So yes, this is a candidate key. This is one of the candidate key, AD. What about BD? You are getting B, you are getting D. Then using B you can get CFH. Using F you can get EG. Yes, this is also candidate key. And you are getting A also. So this is also candidate key. What about ED? Using E you can get A, right? And already if A is there, then that is a candidate key. So this is also a candidate key. What about CD? You are getting C, you are getting D. What else? That's it. This is not a candidate key. What about FD? Using F you can get E. Using E you can get A. That means this is also a candidate key. Right? What about GD? So you will be getting G, you will be getting D. That's it. This is not a candidate key. What about HD? HD, anything else? No, that is also not a candidate key. So if you now you can try to form the combination of three attributes. That means you can consider CG, CDGD, CHDG, right? GHD closure also. Try to find whether we are getting all the attributes or not. And you will see that CH you can get G only. That's it. CG you can not get anything else. So these are also not a candidate key. And even if you form the combination of all the remaining, then also it is not a candidate key. So total 4 candidate keys are there. Total 4 candidate keys are there: AD, BD, ED and FD. So option B is the correct answer over here. Is this clear to all of you? Do you have any doubt? If you have any doubt, please ask. Crystal clear? Shall we proceed now? Okay. So we have already solved this one. Fine. Let's see this one now. GATE CSC 2006. Okay, we need to find out the closure, and we have to find out which one of the following is false. Quickly tell me. What will be the answer over here? Quickly. Do it, everyone. So functional dependencies are given. You need to find the closure and you need to find out which one is incorrect here. Let's try to find out CF closure. We are getting C, we are getting F. What else? Using C we can get G also. Using G we can get A also. What else? Using AF we can get D also. Anything else? Using F we can get E also. And that's it. So A, C, D, A, C, D, E, F, G. Yes, this is true. This is true. What about a BG closure? We are getting B, we are getting G. Then what else? Using G we can get A also. Using A, then that's it. So this is all we are getting, right? So using G we can get A, then we have AB, right? Okay, we have AB. So using AB we can get C and D also. Anything else? E is not there. Okay, F is not there. So that's it. So A, B, C, D, G. A, B, C, D, G, this is also true. This is also true. What about AF closure? So you are getting AF. What else? Using AF you can get D also. Using and that's it. Yeah, that's it. So this is what you are getting. Because you using AF you can get D. We don't have E here. We don't have C also. We don't have, yeah, sorry. Using F we can get E also, right? Yeah, that is also there. Just a minute. Using F we can get E, so E will also be there. Now using DE you can get F, so already there. What else? Using AF you can get D, that is done. That's all, right? We are not getting G because C is also not there. That's it. So AFD, so we can say yes, it is false. What about AB closure? Let's find out the AB closure also. So A is there, B is there, CD is there. Then using C we can get G also. Anything else? That's it. So yes, it is true. A, B, C, D, G, yes, it is true. And this one is false because we are just getting these attributes here. So option C is the correct answer. Option C is the correct answer over here. Is this clear? Any doubt, anyone? Okay, let's proceed to the next question now. GATE CSE 2005. Consider relation scheme R on which of the following functional dependencies hold this. What are the candidate keys of R? Again, similar type of question. Let's quickly do it. You need to find those attributes which are not present on the right hand side of the functional dependency. B is there, D is there, C is there, A is there. That means EH is not there. That means EH must be part of every candidate key. EH must be part of every candidate key. So this is not possible. This is not possible. So let's try just EH, find the closure of EH. So EH is there. What else? Using, you can get C also. Anything else? That's it. Using C, yeah, that's it. Okay. So now, so that means EH itself is not a candidate key. So now if I add A to it, let's find out AEH. If I add B to it, right? Option C you can directly eliminate, right? Because here it is BCH. Carefully see this. This can be directly eliminated. Here it is BCH. EH has to be there. So option C is also incorrect, and obviously now option D will be the correct answer. You can try to find out the closure. You will be getting all the attributes using these. So all these three are the candidate keys for this relation R. So option D is the correct answer over here. Let's proceed further quickly. GATE IT 2006. Consider a relation R with 5 attributes. The following functional dependencies hold, right? Which of the following is a candidate key of R? Again, similar type of question. So WZV is there on the right hand side of the functional dependency. X and Y is not there, so that means XY has to be part of it. So definitely A cannot be the answer because Y is not there, right? Now we have to find out whether, so XY is present here also, here also, here also. Now we need to find which one is the candidate key here. So let's find out VXY closure. So we can find VXY, and what else we can get? So using VY we can get W also, right? Using WX I can get Z also. All 5 attributes, that means this is my candidate key. If this is my candidate key, can I say these are my super keys? So option B is the correct answer over here. Yes or no, everyone? Is this clear or not? B is the candidate key. So any superset of candidate key will be a super key. So option B is the correct answer over here. If you have any doubt, please ask. Okay, let's proceed now. Let's try to solve this GATE IT 2005 question. In a schema with attributes, these dependencies are given. Which of the following functional dependencies not implied by the above set? Not implied by the above set. Not implied means not inferred by the above set. Right? So it is also a very simple question. So let's try to find out CD closure. Option A, CD determines AC. How we can check whether this is implied or not implied? Find out the CD closure using these functional dependencies and then check whether you are getting the AC or not. So if you find the CD closure, you are getting C, you are getting D, what else? Using CD, you can get E also. Using E, you can get A also. So that means A and C is definitely there. So this is implied. This can be implied, or this is implied. What about BD? Determines CD. So let's try to find out the closure. B is there, D is there. Using anything else, B determines D. That's it. So we are not getting C here, no. So this is not implied, because we are not getting C over here. What about BC closure? Whether we are getting CD or not. So B is here, C is here. Using B we can get D. So yes, CD is there, implied. What about AC determines BC? So find out the AC closure. A is there, C is there, B is there because A can determine B. B can determine D also. So yeah, BC we are getting. So this is also implied. Right? So option B is the correct answer here, which is not implied. Which is not implied. Is this clear? Any doubt, anyone? Let's proceed to the next question now. That is from GATE CSE 2024. So very few questions are remaining now. I think 3 to 4 questions are remaining only. So let's quickly solve them. This was asked recently in GATE 2024 set 1. The symbol this arrow indicates functional dependency in the context of a relational database. Which of the following options is or are true? So this is MSQ question. Right? Again, it is a very simple question. Carefully see this. Option A says XY determines ZW. Here it is saying it implies this. Now we need to find whether this is implied or not. Again, the similar type of question, whether this is implied or not. How we can find out? Find out the X closure. And using this one, find out the X closure. If I get somehow ZW, then I can say it is implied. So if I find the X closure, I'm getting just X. Using this one, I'm just getting X. I'm not getting anything else. So this is not implied. This is not implied. This is false. Right? You can say this is false. This is false over here. Yeah, this is false. What about option B? Option B says XY determines ZW and XY determines Z. This is implying this one. So let's find out. Again, XY closure. Are we getting Z? Using this one, are we getting Z? We are getting XY, we are getting Z, we are getting W. Yes, we are getting Z. So this is true. This is true. Right? This is true. What about option C? XY determines Z and W determines Y. We need to use this. And we need to check whether this is implied or not. Again, the same thing. Find out XW closure using this one. So XW, W can determine Y and XY can determine Z. So XW determines Z. Yes. So this is also true. Right? What about option D? X determines Y is there and Y determines Z is there. We need to find whether X determines Z or not. So again, we need to check this one, right? So find out the X closure. So we are getting X. Using X, I can get Y. Using Y, I can get Z. So using X, I can get Z also. So yes, this is also true. This is also true. B, C, D. Correct answer. B, C, D is the correct answer here. Is this clear to all of you? That was the question, MSQ question. Yes, BCD is the correct answer. Very simple question. So you can see inferred or not, implied or not are the same thing. And these type of questions are frequently asked. Now again, a very good question. Carefully see this. This is from GATE CSC 2024 set 2. So let's see this question. A functional dependency if x determines y is termed as a useful functional dependency when if and only if it satisfies all the three conditions. Conditions is x is not the empty set. That means x cannot be an empty set, y cannot be the empty set. Intersection of x and y is the empty set. So are you getting this thing? This is simply saying x determines y, you can say, is useful functional dependency. When it is useful functional dependency, if and only if and only if and only if or simply you can write like this also in short. Just a minute. If and only if when x is not equal to phi, right, or not an empty set, you can say. Similarly, y is not equal to phi and x intersection y is also not equal to phi. Oh, x intersection y is the empty set. So that is you can say is an empty set. That means their intersection is phi. These are the three conditions. Now for a relation R with 4 attributes, the total number of possible useful functional dependencies. This is a really good question. So we need to find, if I have in this relation, if I have 4 attributes, then what can be the possible total number of possible useful functional dependencies that I can form. Now let's try to solve this question over here. See, in the exam, let's say if they ask you this question, if they have given you this question, right? Now what should be the approach? That is very important. So if you have 4 attributes, to find out or to get some idea or to get some approach, let's take less attributes. Let's consider 2 attributes only. This should be the approach during the exam. This is what I'm saying, because 4 attributes is, very big number, right? So now let's consider only 2 attributes are there. Let's say AB are the 2 attributes present. Then what? Then possible number of functional dependencies that I can get is A determines A determines B determines A, B determines B, AB, and here also A determines AB can also be possible. AB determines A is there, AB determines B is there, AB determines AB is there, and here also B determines AB is there. Can I say these are the possible functional dependencies? Are you getting this point? Can I say these are the possible functional dependencies over here? Now based on I'm talking about now useful functional dependencies. How many of these are useful functional dependencies? So useful functional dependency says that the intersection is empty. The intersection is empty. If you consider this one, can I say this is not a useful functional dependency? Intersection is A. This one is useful functional dependency. What about this one? Intersection is not phi. So this one is also not a useful functional dependency. This one is useful. This one not. This one not. This is not useful. This is not useful. And this is not useful. So can I say these are the 2 functional dependencies that are useful? Are you getting this point? Everyone, do you have any doubt so far? Now think about it, how we can get this. Think about it, how we can get this. See, at a time, let's say if I select one attribute, total I have 2 attributes. So if I select, let's say any one attribute. If I select any one attribute, let's say I've selected A, then what can be on the right hand side? Can I say on the right hand side, I will be having those attributes which are not present on the left hand side? That means the remaining attributes. That means the remaining attributes should be there on the right hand side. So the remaining attributes will be what? If I have 2 attributes, I'm selecting one, definitely I will be having 2 minus 1. These will be the remaining attributes, right? So can I say if I have A here, what are the possibilities that I'm having when I have 2 attributes? The possibility is either I'm having B or I'm not having B. Or I'm not having B. But you tell me, so total 2 combinations. But you tell me, is this combination possible? No. Why? Because x is equal to 5, x cannot be equal to 5, and y cannot be equal to 5. That means there can be not, both x and y, both LHS and RHS cannot be empty set. They have to be non-empty. So can I say this you have to remove? When I'm considering two possibilities, this you have to remove. So minus 1. If I select one attribute, similarly, if I select all the attributes, like from 2, I'm selecting all 2 attributes, then I can say 2 minus 2 is the remaining attributes. Minus 1, why? Because I non-empty I'm not allowing. Okay. So if you solve this here, what do you get? So this is 2. 2 minus 1 is 1. So this is going to be 1 only. 2 minus 1 is 1 only. Plus, can I say this will be 0? 2 raised to power 0. 1 minus 1 is 0. So this is what I'm getting. I'm getting 2 only. Is this clear or not? Do you have any doubt? If you have any doubt, please ask. So can I say this is now applicable? Now it can be applicable on 3 attributes also. So we are seeing the complete analysis of this. Let's say we are having 3 attributes. Then is it applicable? Let's say I'm selecting one attribute at a time. What will be the remaining attributes? Why 2 raised to the power something? Because now I have 2 choices whether to include or not to include remaining attributes, whether to include or not to include. So remaining attributes will be 3 minus 1. For every remaining attribute, I have 2 choices whether to include it or not include it or not include it. So 2 raised to the power 3 minus 1 and minus 1 because I want non-empty set. I want non-empty set. Here also it should be non-empty, and this already we are selecting one attribute here in this case, but this should be non-empty. When we can have empty here, when B we are not considering, C we are not considering, obviously this will become empty. That is why we are subtracting minus 1 from this. And then let's say if I select, so we have covered all the cases when I'm selecting one attribute, whether it is A determines something, whether it is B determines something, whether it is C determines something. I have covered all the cases. So it can be A determines A also, A determines B also, A determines C also, A determines BC also. These are the cases for A, right? Similarly for B also, C also, we have covered all the cases here. 3C2, when we are selecting 2 attributes out of 3, then again remaining attribute will be what? 3 minus 2. So again I have for the remaining attribute I have 2 choices, and minus 1 because I want non-empty set. When I'm selecting all the 3 attributes on the left hand side, then the remaining attributes will be 3 minus 3 minus 1. So if you solve this, what do you get? This is going to be 3 into 4 minus, so this is going to be what? So this is going to be 4 minus 1, 3, plus this is going to be what? This is again 3 into 2 minus 1, that is 1, plus this is 2 raised to power 0, 1 minus 1, that is 0 only, so this is 0. So we are getting what? 9 plus 3, that is 12. So 12 functional dependencies. 12 functional dependencies will be possible here. Is this clear to all of you? Do you have any doubt? If you have any doubt, please ask. Okay. So similarly over here, can I generalize this now? Can I generalize this now? Yes, I can generalize. If I have NC1 like this, you can generalize, or directly you can write also, because we have, they are asking for 4 attributes, right? So now we can directly find out also. So 4C1 into 2 raised to the power 4 minus 1 minus 1. Like we have done for 2 attributes, 3 attributes. Similarly, we can find for 4 attributes also. So minus 1 plus 4C2, if I'm selecting 2 attributes on the left hand side, then 2 raised to power 4 minus 2 minus 1 plus 4C3 into 2 raised to power 4 minus 3 minus 1 plus 4C4 into 2 raised to power 4 minus 4 minus 1. If you solve this, what do you get? 4 into 8 minus 1, 7. So 4 into 7 plus, this is going to be 6 into 4 minus 1, 3, plus this is going to be 1 into sorry, 4 into 1, right? 4 into 4 into, this is 2 raised to power 1 minus 1, 1 minus 1, 2 minus 1, that is 1 only. So this is 4. And plus this will be 0. This will be 0. So what do you get? You are getting 28 plus 18 plus 4. So this will give you what? 50. And that is your answer. So total useful functional dependencies will be 50. Total useful functional dependencies will be 50. Is this clear? So this should be the approach in the exam also. You don't have to remember any formula, right? Because you're never going to recall any formula during the exam. So do the analysis, take the less number of attributes, do the analysis, try to find out the pattern. Okay. So this is what we did. We started with 2 attributes, then we did for 3 attributes, and then finally you can just apply that approach for 4 attributes and any number of attributes. I hope it is crystal clear to all of you. Do you have any doubt here? 50 will be the correct answer for this one. Crystal clear. Let's see the last question of today's class, and that is from GATE DA 2024 based on functional dependency. So let's see carefully. Given the relation schema R having these attributes and set of functional dependencies, so this is the set of functional dependencies given to you. Again, the same type of question, which of I'm sorry, which of the following functional dependencies can be derived from the above set? What about this first one? It is similar to that, but not exactly. Samyadip, it is similar to that. That's why I'm saying never ever, never ever go, just remembering the formula. In the GATE exam, that is not going to help you. You will get confused and you will find the incorrect answer. So it's better to go with the approach. Always try to, try to solve these type of questions with simpler example. Because if you are going to remember the formula, that is not going to help you. This is my experience. Never mug up the concept, never remember the formula. Okay. Okay, let's see this now. So which functional dependencies can be derived from this particular set? Now how can we find out? Just simply find out the V closure. And if I get YZ, then I can say yes, it can be derived. So if you find the closure of VW, you are getting V, we are getting W. Then what else? Using V, we can get X also. Okay. What else? So using WX, we can get Z also. Okay. Using WX, we can get Y also. Yes. So now you can say, so using like in the closure of VW, we are getting YZ, right? We are getting YZ. So yes, this can be derived. This can be derived. What about second option? Find out WX closure using the above functional dependency set. So you are getting W, X will be there obviously. Then WX, you are getting Z. WX, you are getting Y. So yes, you are getting YZ. So this can also be derived. What about option C? VW, we already found out the closure, right? You are not getting U here. So this cannot be derived. V determines U cannot be derived from this functional dependency set because in the closure of VW, we are not getting U anywhere. Okay. What about this V determines Y? So Y was already there. So yes, this can also be derived. So the correct answer will be A, B, and D. So this is the correct answer for this question. Any doubt, anyone? This is the correct answer. A, B, D is the correct answer for this one. And this question was asked in GATE DA 2024 based on functional dependency set. Clear? So that's it from this session. And one more announcement, like this is important for GATE DA. So I have already, uploaded the complete module of reasoning under uncertainty. This is there in AI course, right? So that is the complete module. Just one lecture is remaining. Rest all the lectures I have uploaded already on YouTube. So if you want, you can go and watch those lectures. One lecture is remaining. I will be uploading that also in 2 or 3 days. Okay. So this is for GATE DA students if they want to learn this particular important module, reasoning under uncertainty, in this from this course AI. And if you want to get the PDF of this class, or for every class that I'm going to take on YouTube, so you can join our Telegram group. This is the QR code. You can just scan it. Okay. So you can join, and I will be uploading the PDF, annotated PDF, in that Telegram group. Apart from that, you can also join our WhatsApp channel for more updates. I will be uploading a PDF for this session, that the questions that we have solved. Okay. And yeah, so for more updates, so you can connect to us through these channels and Telegram, and also do like the session, share with your friends, and subscribe to MindMatrix Learning. So tomorrow we will be having another session, and we will be solving questions, previous year questions from normalization topic. Okay. Okay, so thank you everyone for joining this. We'll see you in the next one. Till then, take care and bye bye. Thank you all. Good night.